Did you know that the very fabric of our reality might be bubbling with activity, even in what seems to be empty space? Sounds wild, right? Today, we'll dive into the mysterious and mind-bending concept known as quantum foam. Buckle up, because this journey will be unlike anything you've ever imagined. Now first, let's set the stage. Imagine you're standing in a meadow. The grass stretches as far as you can see, interrupted only by a few lazy clouds in the sky. This meadow could be our universe, and the grass its very fabric. But what if we took a magnifying glass, or better yet, an insanely powerful microscope, and zoomed in billions and billions of times, beyond your cells, atoms, and even subatomic particles? What you'd see might blow your mind. Scientists predict you'd find quantum foam, tiny bubbles constantly forming and popping, redefining the concept of empty space. So, what exactly is quantum foam? Let's break it down. Empty space, or what we think is empty, is not truly empty. In classical physics, we've thought of a vacuum as a space totally devoid of matter, energy, or particles. But quantum physics says, not so fast. Due to the principle of quantum uncertainty, what we perceive as empty space is actually teeming with frenetic activity. Imagine a pot of boiling water. Each bubble that rises and pops isn't maintaining its shape for long, it's in constant flux. At the smallest scales, our universe behaves just like that. Quantum foam was first theorized by Nobel Prize-winning physicist John Archibald Wheeler in the 1950s. Wheeler suggested that at what's called the Planck scale, so small it's almost incomprehensible, around 10 to 35 meters, space and time themselves break down into a froth of constantly changing shapes and geometries. It's a seething sea where the rules of classical physics crumble. But wait, you might be wondering, how does this seemingly chaotic froth affect us? Great question. It turns out quantum foam is more than just a theoretical curiosity. It's thought to play a critical role in shaping the universe and everything in it. Let's explore how. A major implication of quantum foam is its relationship to something called vacuum energy. You see, even in empty space, particles and antiparticles can spontaneously appear and annihilate each other, giving rise to what's sometimes called virtual particles. These tiny, ephemeral bursts of energy could, over an insanely long time, contribute to the expansion of the universe itself. In fact, vacuum energy might be the mysterious dark energy that's causing our universe to expand faster and faster. Wild, isn't it? But it doesn't stop there. Quantum foam also ties into the bizarre idea of wormholes. Picture this. Two faraway points in space connected by a tunnel, a shortcut carved through the frothy fabric of space-time. Wheeler and others speculated that quantum foam might create tiny, fleeting wormholes all the time. Most of them are unstable and vanish immediately. But could stable wormholes hold the key to interstellar or even interdimensional travel? Although we're far from confirming that in any practical way, the tantalizing possibility fuels groundbreaking science and science fiction alike. Now here's a twist. Quantum foam might hold important clues about a long-standing mystery: the unification of quantum mechanics and gravity. Gravity, as explained by Einstein's general relativity, governs massive objects like planets and stars. Quantum mechanics, on the other hand, rules the microscopic world of particles and forces. For decades, physicists have struggled to reconcile these two theories, and quantum foam could be the missing link. By studying these foamy fluctuations, scientists can edge closer to the so-called theory of everything, a master equation that explains all of existence. So far, you might be asking yourself, this sounds cool, but how do we know any of this? Have scientists actually seen quantum foam? That's a fair question. Here comes the challenge. Quantum foam operates at an unbelievably tiny scale, far beyond the reach of even our most advanced microscopes. We can't observe it directly, but we infer its presence through experiments and theoretical models. For example, when we study particle interactions in high-energy particle accelerators like the Large Hadron Collider, certain unexplained phenomena could point back to the influence of quantum foam. Even though direct observation remains elusive, technology is catching up. Scientists hope that future advancements in gravitational wave detectors or quantum computers might offer tangible proof of quantum foam's existence. Imagine cracking such a fundamental mystery of the universe. And here's where it gets even weirder. If quantum foam underpins reality itself, does that mean reality is inherently unstable? The short answer, not really. While the frothy nature of space-time might sound chaotic to us, it's more like a symphony of unpredictable yet harmonized elements. So even as quantum foam bubbles, bursts, and reforms at incomprehensible speeds, it ultimately creates the consistent universe we experience every day. Let's take a moment to appreciate that for a second. Right now, as you sit and watch this video, your world feels solid and still. But beneath the surface of everything, from your chair to the air you breathe, is an unimaginably complex ballet of quantum activity. Every atom, every particle, and even the empty space contains multitudes within multitudes, all orchestrated by quantum law. Isn't that awe-inspiring? So what does this mean for humanity as a whole? Understanding quantum foam might be key to unlocking revolutionary new technologies. For example, advances in quantum physics have already given rise to applications like quantum computing, which promises to solve problems far too complex for conventional processors. Who knows what else we could harness from understanding the bubbling undercurrents of space-time? But quantum foam does more than tantalize physicists and engineers. It forces us to confront some profound truths about existence and our place in it. If the very fabric of space-time is inherently frothy, unpredictable, and strange beyond measure, what does that say about our quest for certainty in life? Maybe the universe itself is telling us that uncertainty isn't a flaw but a feature, a fundamental aspect of reality. Now let's quickly recap. What seemed like a simple concept, empty space, is actually a roiling sea of constant activity known as quantum foam. It opens up windows to some of the most profound questions in science, from the origins of the universe to the nature of existence. And while we can't yet see or touch quantum foam, its effects ripple through every corner of the cosmos. And there you have it, the mystifying, exhilarating world of quantum foam. Keep this idea bubbling in your mind, because who knows? By understanding the tiniest building blocks of existence, we might one day unlock the biggest secrets of the universe itself. Until next time, stay curious and keep questioning everything around you.